Hello everyone, welcome back to the channel. If you have been following this Google Earth Engine series, then by now we have already covered some very important topics in previous tutorials. I explained cloud masking, land surface temperature, normalized difference, vegetation index, vegetation condition index, and temperature condition index. So today we're going to combine everything we have learned so far to calculate one of the most important widely used drought monitoring indices, the Vegetation Health Index, commonly known as a VHI. So first of all, we have defined our study area, and if you don't know how to import the study area over here, you can watch my previous tutorials to see this. We only measure temperature stress, vegetation health index, combine both vegetation condition and the temperature condition into a single indicator. So this make it one of the best indicator for the drought, agricultural drought, vegetation stress, and ecosystem health. So by the end of this video, uh, you will learn what is the vegetation health index is, why it is important, how it's calculated, how to implement the VHI formula in Google Earth Engine, how to visualize it, and finally how to export the VHI map as a GeoTIFF. So first, let's explain what VHI is. So VHI was developed to provide the more complete assessment of vegetation health by combining two important indicators. So we're going to use VHI, and so we are going to calculate VHI by using VCI and TCI, that is Vegetation Condition Index and Temperature Condition Index. Now let's begin. The script begins with our pre-processing function, the function mask LH9SR image. So as I have explained in the previous tutorial, this function prepared the Landsat imagery for analysis. It performed the four main tasks: remove clouds and cloud shadow using QA pixel band, remove radiometrically saturated pixels using QA red cell bands, convert the optical bands into surface reflectance using official USGS scaling factor, that's over here, convert the thermal band into land surface temperature in degrees Celsius by using here. After pre-processing, every Landsat image contains clean optical bands and an additional LST bands. So next we load the Landsat 8 imagery. So if we have first variable Landsat, here we have applied EE image collection. We then filter the dataset to our region of interest using dot filter bounds, ROI, that is region of interest. And then next we select all the images acquired during 2021 to 2022 December. And finally, we apply the pre-processing function to every image in the collection by using dot map mask LH9SR. So now we have a clean Landsat image collection ready for the analysis for our study area. Now we have calculated NDVI. Inside another map function, we use image dot normalized difference SR band 5 and SR band 4. This calculates the normalized difference vegetation index using band 5, which is near infrared, and band 4, which is red. The resulting NDVI band is added to every Landsat image. Now each image contains both NDVI and LST. We have calculated NDVI over here, and then we have LST over here. So we have both NDVI and LST at that time. Now we calculate historical minimum NDVI by using this. This identifies the lowest NDVI observed at every pixel during the study period. And similar to that, we have another variable max NDVI that calculate the highest NDVI observed during the same period. So these two images are required to calculate the vegetation condition index. Next, we will calculate historical minimum and maximum land surface temperature like we have calculated NDVI. So first we have a minimum LST that create an image containing the lowest temperature observed at each pixel, and then we have maximum LST create another image containing the highest temperature observed during the study period. So these temperature limits will later be used to calculate the temperature condition index. So finally, we loop through every Landsat image, and inside the function, we have a first calculate VCI. So we have a variable VCI. So this equation is exactly the same as the one we used in the previous tutorial. If you don't understand the VCI, you can see my previous tutorial. And then we have calculated TCI. So this uses the formula minimum LST minus current LST divided by minimum LST minus minimum LST and multiplied by 100. So unlike VCI, we have also tutorial for TCI. If you don't know how to calculate and if you don't know how it works, you can see my previous tutorial for that. So we have calculated VCI and we have also calculated TCI at that point. Now we're going to calculate VHI, that's our main index for today's tutorial. So now it comes the main objective of this tutorial. We combine VCI and TCI. First, JavaScript. First, VCI dot multiply 0.5. So what will it do? Actually, it assigns a weight of 50% to vegetation condition. And then we have TCI multiply 0.5 assigns the remaining 50% to temperature condition. And finally, we have dot add here. We have dot add. So add the both component together to produce a vegetation health index. The output is renamed as a VHI that produces the vegetation and added as a new band to each image. So this calculation is repeated automatically for every Landsat image in the collection. So now we will create a final representative map. So we will calculate the mean for that. So the median over here is a function combines all VHI images and select the median value for every pixel. This helps to reduce the influence of extreme values and produce a more stable representation of vegetation health index. And finally, images clipped to the study area. By using this, we have region of interest. We have already mentioned here. Then we have visualizing the VHI map parameters. We have defined the minimum value and the maximum value, the ranges where the VHI will lie. And then we have palette, the brown, yellow, and green. So I will elaborate further how it gonna show you the VHI. So the brown values represent the poor vegetation health and severe drought, and the yellow represent the moderate vegetation condition, and green will represent a healthy vegetation with minimum stress. So when you run the script, you will immediately see the vegetation health index map displayed in the Google Earth engine. So here is the map. So the brownish area are representing the poor vegetation health and the severe drought conditions may be present over here. This is how vegetation health index is saying us. And finally, we have the export function. We export the VHI image. We will use export dot image dot to drive, and this will send our image to the drive. So first we have image that specifies the VHI raster. Then we have description. The description is basically gives the export task a name. Then we have a scale. Scale preserves the Landsat spatial resolution. We have region, that is ROI, and specifies export's boundary. We have file format, GeoTIFF, saves the result as a GeoTIFF. We have max pixels, that is increased to large study areas, can be exported without error. So after the export is complete, the GeoTIFF file will be available in your Google Drive, or it can be used in ArcPro, QGIS, or any other software you're gonna use. So you can run it from here. So here is our VHI map. So if you have followed the series, you now have a complete workflow of calculating NDVI, LST, VCI, TCI, and VHI using Landsat 8 in Google Earth Engine. An excellent foundation for the drought assessment and vegetation monitoring. So if you found this tutorial helpful, don't forget to like the video, subscribe to the channel, and turn on the notification bell so you don't miss future Google Earth Engine tutorials. Thank you for watching. I'll see you in the next video. Bye.